Again, my name is Victor Digomo here, and in this class, what we are going to be doing is applying the sine rule and the cosine rule derivation we have made in the previous classes to solve a problem like this, just like I promised us. Okay, if you were in the previous class with us, you see how we were able to derive the sine rule and how we were able to derive the cosine rule. That cosine rule, I trust God that you were able to understand it. If you didn't, you can watch that video again and again so that you can be able to follow what we did there. All right. So that in this application, you will not find it difficult to understand what we are going to be doing. All right. Quickly, we want to solve this question. If you look at this question, the question says, this is a cyclic quadrilateral. It's a cyclic quadrilateral. We have a four-sided figure inscribed in a circle. So PQRS, okay. And there's an information that is given to us, not just in this a cyclic quadrilateral. There's also an information that is given to us. That information is that QR is equals to RS, meaning if QR is equals to RS, the implication is that this line is equal to this line. That is the implication. But the question they want us to calculate is RSQ. RSQ, that is this angle there. They want us to calculate this angle here. Of course, you know that this angle here should be equal to this angle here as well. Because of what? Do you know the reason? The reason is because when you have two sides equal in a triangle, that triangle is called an isosceles triangle, and the base angles of isosceles triangles are equal. All right, quickly, without taking our time, how can we be able to calculate this? You see that we have two triangles here. We have two triangles. Do you see this triangle? Do you see this triangle? Do you realize that in this triangle that the three sides are given? The three sides of this triangle are given. That brings us to the condition under which you will use cosine rule. The conditions for you to use sine rule, I explained it when I concluded the class for the derivation of sine rule, but I didn't do so in the class for the derivation of cosine rule because of a time factor. I was trying to beat time there. Now, let me quickly say it here. Do you realize that this triangle has all the three sides available? Now, when you have all the three sides available, but no angle inside that triangle, what you need to use is cosine rule. What you need to use is cosine rule. Please, when you have three sides and no angle inside, because for you to use sine rule, there must be one angle inside that triangle. There must be. And that angle will be facing opposite one of the sides that is also available. But if you look at this, it's not, that condition is not met. So for you to use cosine rule, sine rule here rather, it will not work. So what we use here is cosine rule. Now, another thing again, because I keep on telling students that please, whenever you want to answer any mathematical problem, identify your access point, as in the point through which you can access that problem and handle it. If you realize here, for me to enter this triangle, in this triangle now, there's nothing there. There's no information available inside this place. Only one side is available. No angle, only one side. I can't be able to solve any problem inside here, but I can start from here. Now, when I was handling circuit theorems, did you see that theorem that says opposite angles of cyclic quadrilaterals are supplementary? If you were there, you will see that theorem, and you will see that I need to borrow that theorem, or we need to borrow that theorem right now. Because if I can calculate this angle here at P, I can now say that this angle here plus this angle at R are supplementary. I'm sure that is good enough. So let's go. Quickly, I will say solving for P. Okay, solving for P using cosine rule. Okay, using cosine rule. I will state that cosine rule that cos P is equals to Q squared. If you followed me when I was giving you the idea on how to write the cosine formulas, 6 of them, there's something I said there. Q squared plus S squared, then you remove P squared, then divide by 2 times this and this, QS. So that is it. This will be equals to Q is 7 squared plus S, the side facing X is 8, minus the small letter P is 7.5 squared, all over 2 times 7 times 8. This will give us, of course, this will be 49 plus 8 times 8 is 64, then minus 7.5 times 7.5. My calculator. Or let me borrow the figure I have here already. That's 56.25. 56.25. Then all over 2 times 7 is 14 times 8. That is 112 by my figure here. Yeah, 112. So let me come over here. 49 plus 64. You can do it in your calculator. I'm sure you have one there. So 49 plus 64 minus this gave me 56.56. Excuse me. Let me write this first. Cos P will be equals to 56.75 over 112. Then cos P will be equals to, this will be 0.5066 by my calculation. Please, you should also check in yours to verify this if there is any mistake there, but I don't think so. So what is P? We take the cos inverse of 0.5066. Okay, so the angle here is the cos inverse of my calculation is 59.56 degrees. So approximately 60 degrees, but let me leave it at that decimal point. 59.6 degrees. That's the angle there. Does that make sense to us? Yeah, I think so. I think so. So now, based on the previous explanation I was giving, I said that since this is a cyclic quadrilateral, that the opposite angles of a cyclic quadrilateral are what? Do you remember what I said? They are supplementary. All right. So we can come back again and say, since this angle P plus the angle R is equals to 180 degrees. Why? Please state that theorem. Say why. The why is that opposite OPPT angles of cyclic quadrilateral are supplementary. SUP are supplementary. Having said this, we will say that 59.6 degree plus the angle at R is equals to 180 degrees. All right, we can proceed and say, what is R? So R will be equal to 180 minus 59.6 degrees. That is the angle that will be here. Okay. So R, the angle there will be, by my figure here, 120.4. 120.4 degrees. Please verify that. Verify that. It's just doing a difference. Okay. So if this angle here is 120.4 degrees, the base angles will be equal by the explanation I gave previously, and we can now say that from that triangle QRS, you now know that the angle at Q plus the angle at R plus the angle at X is equal to 180 degrees. Why? Sum by sum of angles in a triangle. Okay. So, and you know that these two angles are the same. So I can say 2Q, 2 times this angle at Q. You know why? Because they are the same. They are the same. So plus the angle at R, okay, is equals to 180 degrees. So I can have 2Q plus 120.4 degrees is equals to 180 degrees. That means 2Q is equals to 180 minus 120.4 degrees. So that we have 2Q is equals to that difference there. Let me check what is going to give us. We have 180 minus 120.4. So that's 59.6. Okay. Oh, that's good, because that should give us that 59.6 degrees, because they are supplementary. So that we can now have Q. The angle at Q will be equals to that 59.6 degrees divided by 2. And that will give us what? Divided by 2 equals to 29.8. 29.8 degrees. So you now know that RSQ. You now know, let me expound it here, that R here, RSQ, which they ask us to find, which is also the same thing as RQS. QS, those base angles, they are equal, is equals to 29.8 degrees. So this is the result we are able to obtain from this calculation. I'm sure it's sweet. Okay, I'm sure it is a very, very wonderful. I believe the understanding, you were able to capture it. Please, you can look at it again and again. You can go through the explanations I've given here. Please go through it again and again, so that you can be able to understand every detail. Detail is important, so that you don't just, understanding is very, very important. So when you understand it, you can be able to apply it in the problem you might be facing out there. Okay. We are not exhausted what we have here. We want to take another example in another class. Please, when you subscribe to the channel, you have access to over 100 plus classes we've had already, okay, in different topics. You'll be able to access them, and then like our video, and then share to your friends out there. That's the way you encourage us in what we are doing. When you do that, God bless you.